Yes. Yes. Uh, Current transformers. Today we are going to discuss about the current transformers. So far what we discussed is about the loads we have discussed. Okay, am I audible? We discussed about the loads. We discussed about the power distribution. Okay, we discussed about. Then we discussed about design criteria. Am I audible? Okay. So
Yes, you are.
hello. Am I audible?
Hello. Yes, sir, you are.
Yes, audible.
Is it okay?
Yes, sir.
Okay.
Very much clear.
Okay. So we were discussing about the loads, power distribution. Okay. And yesterday we discussed about the transformers. Okay, we discussed about MV switchgear. Okay, switchgear we discussed. So now any the important part of any power systems, if you see here, very much what we required what you can call as a current transformers. Correct? We required a current transformers, and also we require to have a potential transformers. So what the current transformer does, can anyone tell? One for a measurement
Measurement of current.
Measurement and protection.
and protection, correct? And the
Protect.
protection. Okay. So we are going to discuss about what is the play of type of current transformers and the how this plays an important role in a power system basically. Okay. So these CT codes and the standards as per IEC 618692. We are going to discuss about CT basics, course selections basically for LT, MV, HV, and EHV. CT voltage and primary service current calculations, CT metering, CT selection criteria, Nippon voltage calculation, CBCT, and NCT. So in any of these things, when you see here, we have like a this is we have a different type of CTs are there. Okay, so we are going to discuss about the phase CTs. We also call it as a phase CTs. Then we have a neutral CTs. Okay, then we have CBCT, core balance CT. So whenever you have a transformer like this, okay, so we have like this. Then we use the two type of CT, one for REF protection and another for standby earthwork protections. Okay, two CTs we are going to use, and these are called as a phase CTs. These are called as a phase CTs. So that's how it is. 1 second, someone is joining. Yeah. So the phase CTs measurement. In this we have phase CTs. One is measurement CT and another is protection CT. In that protection CT also 5P10 or a 20, we have a PX class. Okay, that nothing but a special core CTs are required. So three type of CTs are going to come over here. Then we have a what you can say that we have the neutral CT basically, which is of restricted fault and standby fault protection. And also we have what we can have like for a motor feeder, we have a core balance CT, CBCT, what we can call it as a CBCT. Okay, so and today's in class we are going to discuss about CT codes and standards, CT basics, selection of CTs, CT voltage and primary service current calculation, CT metering, and the CT selection criteria, Nippon voltage, CBCT, and NCT. This is called as NCT for the transformers. Okay, so a current transformer basically designed to produce a secondary current, okay, which is accurately proportional to the primary current. Means what? You have a current, suppose this is your CT, okay, and you have a 100 amps CT ratio is 100/1, and then you are connected to ammeter. If suppose 100 amps current is flowing, what is the secondary it is going to cut? If 100 amps going, then what is the secondary current in amps? Can anyone tell?
How much was the CT rating?
We have a CT, for example, we have a CT 100/1, and suppose we have a 50 amps is flowing here. What is the secondary current now?
Yeah, 0.5.
Yes, exactly. Because if 50 is there, then 50% of this one will be 0.5. Similarly, if it is 100/5 ratio is there, then it will be 2.5. If it is 100 amps flowing, full current is flowing, then it will be what? It will be 1 amp. Yes, please. Yes,
So this is basically on the turn ratio, right?
exactly. It's a turn ratio. Okay. So basically,
Yeah.
you have a 100 amp CT is there. Actually, primary is the 100 amps flowing, but proportionally it will give a 1 amp CT. Okay, 1 amps current, because you cannot measure the 100 amps. Is it possible to measure 100 amps? Hmm?
No.
Difficult. It is okay.
I,
100 still is okay. If you have a 2000, 3000 amps, it is possible to measure the current? No. So proportionally, it will convert into the 1 amps, and accordingly it will be measured. Clear?
okay. Yeah. Thank you.
That is what the meaning of that one. Okay. And so produce secondary current which is accurately proportional to primary. It consists of a single primary winding which an external bus bar cable runs through, and it can have a single primary bar brought out two leads and end of termination. A medium voltage current transformer to have a 3 independent secondary winding sets, and the entire current transformer assembly is encapsulated in a resin inside the insulated casing. So the purpose of CT is to, as we know, ammeter and voltmeter used to measure the current and the voltage, metering purposes and protection relays used for the protection purpose. So we have a current and voltage metering purposes, and the protective relay has been used for the protection purpose. So those metering and equipment relays are made up of power electronic equipment designed for very low current as much as 1 amps and 5 amps. So all these meters are rated, either relays are rated for 1 amps or 5 amps. Due to this reason of ammeter and voltmeter product cannot measure directly to the high current or high voltage, therefore CTPTs are used in between the meters. Okay, in between, used between the meters, ammeter and voltmeter, and high voltage conductor. So to it will able to measure the current of the primary. Okay, so and thus the high current and high voltage simply measured by meters, ammeter and voltmeter. So what is the measure we are doing? We are measuring the current and we are measuring the voltage. These are the two active component only we are measuring. Okay, by using the CT we are measuring the current, using the PT we are measuring the voltages. Then accordingly further these input data will be given to what? MFM. So further it will calculate your kW and power factor, all those things will be calculated, kVAR. Okay, so only current and the voltage only you are measuring. Please understand this point very well. And the also important is how much accuracy of your meter and how much accuracy of a CT is important to measure the accuracy of your primer current. So the CT selection and the multi-core CTs. See, now we know general method of number of core selection for multi-core CTs. Okay, so here when you see a one core CT is used, and that only for LV system. When you go to the LV system, we are talking about what? MCC level. Okay, here we are only using the single core CT. One core CT has been used, and that is only for the metering purposes. So suppose you have a MCC. Okay, if you see here, only I am going to use one single core that is used for the meter, that is metering purpose, ammeter. Okay, here also same thing. So you might have seen that a single phase CT will be used in the Y phase to measure the single phase current. If you want to have a 3-phase current, then 3 CTs has to be used, and with ammeter and emitter selector switch. So, and other than that, everything like you have a ACB, everything will be having the LSIG protection. Whatever you are using the at incomer side, at this incomer, which is MCCB or ACB, we are not using the separate CT for the protection. Only the CT which is used for metering purposes. ACB and the MCCB is having a inbuilt LSIG, overload, short circuit, instantaneous, and earth fault. Okay. Now, when you see like this, so now what we learned like this, we have a MCC. We have a MCC. Now this CT I am called for ammeter, and this is LSIG, which is of MCCB. Now I have a what PCC, which is feeding to here. So this is my PCC. So now when you see here, now there are chances that here I am using the 2 core CTs. I am using the 2 core CTs basically. I am using 2 core CTs here. And here I am using again single core CT I am going to use. So these are basically most of the time these are ACB. Okay, these are all ACBs. Okay, and here ACB is there, but it is like act like a disconnector switch. So here I am going to use a 2 core CT, one for ammeter, other for protection. So this is protection I am using. So that is what now I am using only one meter, but here I am using the 2 CTs, one for metering and the protection. So that's what we are written here. Whereas LVPCC panel, we can take a 2 core CT, one for metering and one for protection. Separate numerical relay is used for the protection purposes. So here I am using separate numerical relay. So one is for ammeter, another for protection. Okay. Okay. That is what it is all about. Okay. So now understood. So when it comes to MCC level, I'm using only one CT for metering purpose. When you come to the PCC incomer level or even some outgoing level also, may people use 2 core CTs, one for metering and another for protection, and ACBs which are used only for the isolation purposes. So here this will be used for like this. Okay, and next will be when it comes to MV feeder. MV also I am going to have a 2 core CT, one for a metering, another for the non-directional overcurrent and earth fault. Means what? I am having, this is my a medium voltage. This is medium voltage transformer. This is my motor, and this again the transformer which is feeding to my LCC. So here you can see, here I am going to use 2 core CT. Again I am going to use the 2 core CT. Here also I am using the 2 core CT. Outgoing side also I am using the 2 core CTs. Here also I am using the 2 core CTs, one for a metering, another for a protection. And sometimes I may use the 3 core CTs, one for a metering, other for a protection. Protection means what? 50, 51, 50. Here I am using for the cable differential protection. Here also I am using the 3 core CT sometimes. What is that another CT? That CT will be basically bus bar differential I am using. Bus bar differential. So as we are going from LV MCC, then I am going for a PCC, then I am going for a medium voltage switchgear. My protection requirement is goes on increases. For 11 kV or 33 kV, bus bar differential also will be using. That is called as a special core CT I am using. Clear? Any doubt up to here? So medium voltage, 3 core CT, metering, directional, basically non-directional, overcurrent and earth fault, and transformer differential, bus bar differential, or cable differential. When you go to 66 and 132 kV system, We are using 4 core cities, okay, or a 5 core cities, one for metering, another for directional overcurrent and earth fault, or a non-directional overcurrent and earth fault, a line differential protections, then a bus bar differential protections will be used. Then again, when you go to 220 kV and above, we use 5 core city metering to distance. We are using for distance, overcurrent earth fault, and the differential protections. Okay, so this is how, when you go from low voltage to medium voltages, I keep on increasing the protection requirement basically. Okay, so that is how we required these CTs and the protection from one voltage to other voltage. Yes, please.
Uh, why are we using two numbers for the bus bar differential and
What
again two numbers for
no,
the distance protection for say for one feeder? I guess this is for say this is for one feeder. For example, the
no,
220 kV feeder.
yeah,
If it is one feeder for one bay,
yeah,
I guess in each bay or each feeder will have 5 core, and each of these core, one will be used for metering, two for distance, and two for bus bar differential. Why we?
yeah.
What is the purpose of using two for distance protection
Yeah, basically you
and
can
two
see
for bus?
one is metering. Okay, here busbar differential, one is check and another normal busbar differential. It will be used 2 core city. It will be used, and distance. I think it will be. I think it is a mistake. It will be one for the distance, and another 2 core city will be used. One for the main, another for the backup. Basically, one, two, two, three, four, and the five. Even sometimes 6 core city also will be one. Another core will be used for the a spare core also will be used.
What is this main and check? Is it like a
Main,
backup and
yes, exactly. One is main and another is a backup protection. Then they use two different make of relay will be used. Clear? Yes, please.
I want to ask, the toroidal CT is the same as the single core CT, or is a type of single core CT?
Where? Come again? Come again?
Toroidal CT is the same as the single core CT, or a type of single core CT?
It is a single core CT basically. It is a three-phase, all three-phase. It's basically you're asking about the core balance CTs, correct? CBCTs.
So they are the same.
Yes,
Yes.
it is basically to measure the your insulation earth fault protection detection, where all the three phases together put it in a one single cities, and they measure the earth fault detection. There is a earth fault leakage or current, it will be detected basically. Yes, please. Yes.
for the 220 kV systems? Why don't we use overcurrent earth fall IDMT? Uh,
Overcurrent earth fault, it will be used, no, because we are using the 6767N. It will be used. See here, there is some typographical error is there. One for a metering is done. Okay, the second core, it will be basically one for a distance, it is done. Then another 2 core basically, as I told, one for the main, another for the backup. So main is nothing but your 50 51 67 67N. Similar will be there, but it's a backup protection. This will be used ABB make, and this will be used by Siemens make, some other things. And then we have a differential protections.
so within the same core, can we
Yes,
connect the main and the backup?
with one same core will not be. The 2 core will be there. One for the this will be 5P20 core, like it will be having like this. Core 1, it is for metering. Core 2, 50, 51. Core 3, backup, same protection. Then core 4, basically I have a distance, okay, or even line differential protection. Then core 5, I have a bus bar differential check and the main. So differential protection will be there. Then if anything we have like a transformer differential, one more core also will be there. Clear?
Yes. So for the bus bar, it is just one core
Yeah,
that will be used for the main and check.
the main and the check. Yes.
But for the distance, you're saying that two separate cores will be used, one
Yes,
for main as well as,
yes.
sorry, for the overcurrent, you mean?
Overcurrent,
And
yes.
yeah, one for the main and back.
Yeah, distance or line differential. Either of the things they will use.
How do we choose whether it is for the distance or line differential?
Like
Is
depends
it the
upon,
same?
is it, it's the same. Line differential is nothing but it is worked on the two ends. You will have a sending end, receiving end, line differential will be there. But in distance it will not be there. Depending upon the particular zone, they'll make the zone, and then accordingly they will protect the particular area wise. They make the zones basically. Okay, on that principle it will work on it, but
Yeah.
not on the line differential. Line differential you will have like a, this is like this, okay, and like this we have like this. Here I have a CT, here I have a CT. So here I am going to use like this. So there is a sending end and there is a receiving end. Then there is a CT. So if there is any cable cut or anything, this CT will able, this protection relay will be used. But in the distance protection, this will not be there. Only based on the distance, it will be able to detect the fault particular zone that will be able to trip the breakers.
Yeah. This outgoing and incomer base which you have mentioned, it's only for the feeders, not for the transformer
No,
feeders, right?
it's only a, between the two end feeders basically. It is basically most of the time it's a power feeder basically. It will be used. Suppose you are going this substation, another substation. Okay, we have a 1 kilometer, 2 kilometer power feeder, but it is in transformer we have a transformer differential protection. This will not be there. Basically. Cable differential will not be clear.
Yeah. 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 Thanks.
Okay, so that is how you understood understand this thing. And also very important, like whenever you have CTs, please also understand, people may ask like this, we have a CTs, this will make a one CTs, core 1, core 2. Okay, so the same CT will be represented like this, core 1, say core 1, and we have a core 2. Is there any difference between this diagram and this diagram? Do you find anything, any differences?
And the first one, it's one CT
Hmm.
which has two cores, and the second one, it is two separate CTs
Okay, very
having
good.
just one core.
Okay, correct. So what is the advantages?
If it is just one CT, then your cost will be lower, right?
Okay,
Just
apart from that,
thought.
apart from that, suppose if there is any fault occurs or any problems occur, then both the cores will be problem. Here it is not like that. Here one CT has a problem, still this CT you can use it. Okay, that is what it meant for it. So, uh, understood?
So, yeah,
Yeah. Okay. So now one
I
thing
have
is,
one question here.
yes, please.
Sorry.
Yes, please. No, you can.
I mean, which one do you prefer to use it?
Normally,
Like two separate
if
ones?
you see, I want to, if you have economical, this is okay. CT failure, okay. Failure means anyway the failure occur. This CT also working very well. But if you have a process
Mhm.
where the process is there, where you want to have a built a stringent, or you want to rugged your system, then I will some of the standards. Some of the standards where in like a KOC or some of the public sector, they will ask for the two sets of CT, separate CT for the meeting, separate CT for the this one. Here, if any failure occur, other CT can take care. But here, one failure occur, whole CT will be problematic. The reliability point of. Okay, this is always a better. Okay, this is always a better.
Okay.
If you see, and cost is more. If you have a one or two feeder, fine. If you have a hundreds of feeder, you imagine, no? Correct.
Yeah.
Yeah, that you need to understand.
So just one last question. Are we going to see through it the SLDs?
Yeah, we that is will be on The next it will be on Monday, next coming Monday, the SLDs we are going to discuss. Complete SLDs and
Okay.
all, everything we are
I
going to
mean,
discuss.
this
Complete
CT.
with CT, meter, protection, all those things we are going to discuss
Okay.
on that one. Because unless until we don't cover up, the CT is also part of SLD, then cable is also part of SLD, MV switchgear we studied about, then you need to construct this SLDs, with I'm talking about now only component wise. Now once we cover up this, tomorrow the cable will be there. Once we cover up the cable, definitely we are going to talk on the SLDs.
Okay, sir.
Start from the MV, start from the MCC, TCC, MV, HV, all SLDs we are able to discuss on that. Then after that, I will give you one exercise to you people to make an SLD on your own, because most of the calculation we have been completed. Okay. Yeah. So now when you see a little bit one Excel sheet, I have prepared it. Okay. So okay. So once you see here, for example, we have a. Can you able to see Excel sheet?
Yes.
Okay. So we have a 1000 kVA transformer, 1600, 2000 and 2500. Okay. So here at 433, we in India we call 433 secondary voltage, no load voltage. At 1000, if we calculate, it will be 1333 amps. At 1600, it is 21333. Okay, that is current at the 433. Okay, and 2000 466, 2667, and 2500 3334. This is your, what we can call it as the current for these transformer at 433. If you want further, you want to take fifth, what you can say, that 3000 kVA, 3000 kVA, then so this will become, sorry, this will, anyway, this we will see it, C3, not C3, B7, B7 divided by, anyway, with that we will see it. Okay, so here when you see here, it is 1333 and 1000 and 3000, it is basically almost 4000 amps basically. So here by default for 1000 kVA, because of this one, if we can consider say around 10% extra, then 1600 bar 6, 1600 1 dash 1. If 2133, I can select 2500 bar 1 dash 1. 2667, I will select 3200 1 dash 1. For 3334, I am selecting 4001 bar 1. This is even you can easily remember. For 1000 ampere, you can select directly 1600. ACB also selected 1600 and for this one you can directly select 2500, because these are all ACB rating. If you see here, for any of these transformer, the secondary current, my ACB is 1600, 2500, 3200 and 4000 amps. Okay, that is how I am going to select it. Normally it will be 10% than your full load current. Now when you calculate at 6600 volt, that is on the primary side. For 1000 kVA, it is 87 amps. For 1600 kVA, it is 2500 bar 1. And for 2000 kVA, it is 3200 bar 1. Sorry, for 1000, it is 87 amps, 1600 140. And the 2000, basically, it is 1175. And for the what you can say, that 2500, it is 219 amps. Okay, so here I have selected 10 to 20% extra you need to consider. Why you need to consider extra while correct? This is basically to calculate the CT ratio. This is what I am talking about for calculation of CT ratios. So here multiplying with 10 or 20%, this is the full load current. So 105, 168, and accordingly I will select. You can also select 120 or 110 also, but standard I selected 125, 200, 225 and 10 amps. At 11 kV, 52, 84, 105, 131 for these rating of transformers. Okay, then